Our next rule is a big one. This is known as the power rule. This is used very specifically when we have the base of a variable and the exponent is a constant. So our monomial kind of idea here. But that's important here. Base is a variable, exponent is constant. And the way this works is for our derivative, the exponent comes down in front, and then we subtract 1 to get our new exponent. Big key here, the base never, ever, ever changes. So if our base was an x in the original function, the base stays an x. It's the exponent comes down and subtract 1 to get our new exponent. So this works for pretty much any type of exponent you can think of. If you look in our textbook breaks it up and says, well, this works for positive whole number or positive integers, then negative integers, then rational numbers, then irrational numbers. But the key is this is true no matter what, as long as we have a variable base, constant, exponent. So an example of this would be if y is equal to x to the 4/3, well then dy dx, 4/3 would come down in front, base stays the same, subtract 1 to get our new exponent. And there is our x. There's how that works. This also works for our radicals. What you're going to notice very quickly is that radicals are not very friendly to calculus. Typically, if we see a radical and we want to do calculus with it, we're going to change the radical into an exponent. So for example, the 4th root of x is the same as x to the 1/4 power. Because in radical form, we don't actually have a shortcut. But when I change the radical into an exponent, I now have the power rule that allows me to quickly find that y prime. 1/4 comes down in front, base stays the same, subtract 1 to get my new exponent. Now, if I wanted to change this back into a radical, first I would have to deal with a negative exponent. So remember, negative exponents do the reciprocal of the base. And that would be 1/4 times the 4th root of x cubed. Some additional practice with this is if I look at y equals x, this causes some difficulty sometimes. For some people, if you just remember that derivative is the slope, what would be the slope of f of x equals x? Well, it's a line with a slope of 1. So the derivative is 1. But we can also even apply the power rule to this because this is the same as saying f of x is equal to x to the 1st. So I have a variable base constant exponent. So for f prime of x, the exponent comes down in front, base stays the same, subtract 1 to get my new exponent. But then remember that anything raised to the 0 power is equal to 1. And then just some nice additional practice for f of x equals the square root of x. This is one we're going to see pretty frequently. I can change the radical into an exponent, like I did with the 1/4 power above it. I have a variable base, constant exponent, so I can go ahead and find the derivative using the power rule. The 1/2 comes in front, base stays the same, subtract 1 to get my new exponent. And that's perfectly correct how it's written because we don't need to simplify it. But if I wanted to change it back into radical form to match my function, first deal with the negative exponent, and now change that exponent back into a radical, I have 1/2 times the square root of x.